Today's Nonsense Wars production looks at my 1/48 scale Pennsylvania Railroad Baldwin RF-16 version 3. Baldwin produced more than 100 of these diesel-electric locomotives in the early 50s, with the vast majority going to the PRR. I like these engines for the iconic shark nose styling, which is reminiscent of the more famous T1 and much more unique than the bulldog noses on the much more common EMD-E and F units. I actually designed and built the first version of this model in 2014. Powered by two M motors, it became my first reliable power functions engine despite some questionable building techniques. However, at the time, I needed more locomotives that could run ahead of 9-volt power cars, and I removed the motors from the second version, effectively making it a rolling shell. Since then, I hadn't done anything to the RF-16, so I felt like it was time for an experimental build. Power functions runs at 9 volts, so in theory, two 4.5 volt motors running in series should work like one bigger 9-volt motor, and I had wanted to try to assess the performance of this setup as early as my original leader build. I certainly looked into it again when I converted that model to PF, but I could not find a way to fit the battery box and receiver along with the two motors and drivetrain. With the leader working properly and some free 4.5 volt motors, I wanted to revisit this idea, and the more or less mothballed RF-16 seemed like the perfect platform. As usual, this sort of thing always begins with some testing. In this case, I needed to ascertain the proper gear ratio to use with the 4.5 volt motors, having failed to adequately nail this down in the leader. The gear ratio will then limit the number and type of gears I can use, which will then shape the layout of the actual drivetrain, and most importantly, determine whether it will actually fit. To make things more complicated, I wanted to use a first stage belt in order to reduce gear grinding and also have some wiggle room to adjust the gear ratio up or down a little if necessary. My previous experience with the leader suggested that a net ratio of 1:9 would suffice, and further testing with the motors suggested the same. While doing this testing, I noticed that the motors had a hard time starting at low power, especially when starting cold, and they would not consistently start at the same speed. I could not figure out if this happened because of the wiring or mechanical setup, or because of quality or condition differences between the motors. Then again, these motors were never designed to run at anything other than full speed. Either way, if the two motors drove the front and rear bogies independently, one drivetrain could slip while the other continued to stall, and I decided the two halves needed to be linked as in the T1 tender. Adding this connecting shaft, of course, increased the complexity of the drivetrain, but I inserted it utilizing the additional width of the 8-wide car body, and even kept my slightly adjustable 1:9 gear ratio. I use universal joints here to reduce friction due to slop or bending, on an axle going through multiple holes. As with the leader, a small PF battery box goes under the locomotive. Again, a trade-off in order to keep the receiver in a reasonable spot. Now about the wiring. I'm a self-proclaimed purist when it comes to Lego, but this wiring clearly doesn't look it. However, I'm going to insist that it is purist because A, it's electrical, so I'm giving it a bit of slop, and B, it could be done with all Lego parts, and potentially without even cutting anything. With the 4.5 volt and 12 volt cables, the wiring is screwed into the connectors, so any connector could attach to any wire. With the 9 volt cables, the connector doesn't easily open, but they can be reversibly opened and wires spliced in with minimal damage to the wire. I mainly used third-party wiring in this case because I needed to replace the wires on this specific 9 volt cable already. Overall, this implementation of the RF-16 behaves kind of like my U30B, which uses the ungeared 9 volt motors from the early 90s. Nonetheless, the 4.5 volt motors don't seem to have quite the same amount of maximum power or torque, perhaps rightfully so. Still, the unit is heavy enough and strong enough to break magnets, though it requires almost full power to do so. On the low power side of the spectrum, the engine does run at notch 1 and can actually pull a car or two at notch 2, though starting at those power settings is more difficult. Also, during testing, the Loco seemed to drain battery somewhat quickly and slow down a bit after running a while. The motors did not feel particularly warm, so I don't think it's using that much power or overheating, but since I'm building and filming this during the C19 quarantine, I won't be able to do much real-life testing for a while. On that note, this is the end of the video, so have a nice day.